Hello, everybody. Welcome to the back page. So, same candies, same bag of Skittles and M&Ms. But this time I'm drawing more than one candy, but whenever I draw them, I put them back before I draw the next one. There's a name for this. It's called drawing with replacement, which you may have heard. And it means just what it sounds like. It just means I replace the candies when I draw them. And the reason that it's important is because when you are drawing with replacement, it means that the draws are independent events. And the intuition behind an independent event is just that the probability of each event is independent of anything else. It isn't affected by anything else. So whatever you happen to draw last time isn't affecting the probabilities of what you're drawing this time. So independent events, probabilities are unchanged by prior events or prior draws. Okay, and so this is going to turn out to be really important when we're thinking about like the quote-unquote and rule from the front. So let's dive in. I draw twice. What's the probability I end up with 2 Skittles? So you can think about this as 2 separate events. The probability that I draw a Skittle first, and then the probability that I draw a Skittle next. Because these events are independent, like the probability of me drawing a Skittle second is just the same as the probability of me drawing it first, because my first draw can't possibly have changed the number of Skittles or the total amount of candies or anything that would affect the probability. So this is just probability of Skittle times probability of Skittle. So the quote-unquote rule here is that to find the probability of multiple independent events, you just multiply the probabilities separately. But that only works for independent events. You might be wondering why multiply, and we will come back to that question. Hopefully you know already, but we'll come back if you don't. So again, the probability of getting a Skittle is 20 over 40. We multiply that by another 20 over 40. Hopefully you remember that that is 20 over 40 squared. Okay, so let's try and apply that same idea here. What's the probability that after drawing twice, I end up with a yellow candy and a green candy? So you might think this way. You might think, let's do probability of getting yellow and then times probability of getting green. Because my first draw, the probability is independent of my second draw. So I can just separate the 2 separate questions. So the probability of getting yellow is 7 over 40. The probability of green is 6 over 40. But that's not quite the answer yet, because this way of calculating the probabilities has only told me the overall chance that the first thing I drew is yellow and the second thing I drew was green. But I could also get a yellow and a green if I'd drawn them in the other ordering. So I also need to calculate the probability that I got a green on my first draw and a yellow on my second draw. So that'll be 6 over 40 and 7 over 40. And so these are all the different ways that I could have gotten a yellow and a green. And so I'll add those probabilities together for my true probability. You might notice that the term on the left is the same as the term on the right. I can just change the ordering that they're multiplied in. So a good final answer here would be 2 times 6 times 7 over 40 times 40, or 40 squared. And again, we're not really simplifying so that we can kind of see where the numbers came from. So if you're looking for something to hold on to here, what we've just learned is that you want to add all of the different probabilities for all of the different ways or all of the different orders that would end in the event you're trying to find the probability of. And this is kind of back to the first page where you want to figure out what are all the ways that you could get the outcome you want divided by all the things that might happen. So in that spirit, I'm going to draw 3 candies. What's the probability I end up with exactly 1 Skittle? So there's 3 different ways that could happen. I get a Skittle and an M&M and an M&M in that order. So I draw the Skittle first. I could draw the Skittle second, or I could draw the Skittle third. Each of these, the probability of each of these happening turns out to be the same. So the probability of getting a Skittle is 20 over 40. so that's the probability of drawing a Skittle first. The probability of drawing an M&M next is 20 over 40, and then an M&M next is another 20 over 40. But that's exactly the same for the next two. The probability of getting an M&M, 20 over 40. A Skittle, another 20 over 40. Because each time I'm drawing, I've put back my old candy. So nothing is changing to change the calculation from the first page. So it's always however many M&Ms there are over the candies or however many Skittles there are over the candies. So the final answer here is just 3 times that number, and that number is 20 over 40 to the third power, because I've multiplied it by itself 3 times, and so that's this 3, and then I've done that in 3 possible orderings that I've added together. So that's that 3. 3 times the 20 over 40 to the third. Okay, so the next two are related. So I draw 6 candies. What's the probability I end up with no Skittles? So if I get no Skittles, that must mean I drew an M&M, and then another M&M, and then another M&M, and then another one, and another one, and another one. So 6 M&Ms in a row. So the probability of drawing an M&M is that same 20 over 40. But I'm going to multiply that by itself 6 times because of each independent event. So the answer is 20 over 40 to the 6th. Okay, but let's contrast that here. If I draw 6 candies, what's the probability I end up with at least 1 Skittle? So if I try and calculate this directly, it's going to be terrible. Because think about all of the different ways I might end up with at least 1 Skittle. So I might end up with exactly 1 Skittle, but there's a lot of different ways that could happen. I could draw the Skittle first, or second, or third, or fourth, or fifth, or sixth. But it doesn't say I end up with exactly 1. It says at least 1. So I also could have ended up with 2. And there's a lot of different orders that I could have drawn 2 Skittles in. Or I could have ended up with 3 Skittles, and there's a lot of orders for that also. So if I was going to try and add up all the different possibilities where I end up with at least 1 Skittle, the way I was trying to do it up here, that's a lot of possibilities to add up. So let's use the complement trick from the first page. What if I try and find the complement of the situation? So if I don't end up with at least 1 Skittle, that means that I've got no Skittles. And that was relatively straightforward to find the probability of. So the answer here is the probability of at least 1 Skittle is 1 minus the probability of no Skittles. And this is where the idea of the complementary situation is really, really helpful, because we don't have to do a ton of math. It's just 1 minus 20 over 40 to the 6th power. Hopefully we're feeling good there. Okay, come back for round 3.